All right, you guys, number 8, right? Now, what we're doing here is a very similar skill to what we did back in a previous question, right? Given the reactants with the correct formulas for the reactants, you now have to figure out what those products ought to be, right? Then go back and add that next layer of balance. So this is just basically a continuation of that question. Now we're assessing whether you can then appropriately balance these as well. All right? So we're going to have to combine some knowledge in this case. And it looks to me like we have an A plus BC type reaction. So a single replacement reaction. So in this case, I would predict that aluminum will replace the hydrogen. Okay? Now, on this side, so I'm going to basically create aluminum nitrate. So I'm going to have Al and NO3 combined into a single compound. Now, nitrate, I know, has a -1 charge. Aluminum has a 3+ charge when it's an ion, which means I'm going to have to assign that 3 to nitrates because I'm going to need 3 of those to balance that out. And because nitrate's a -1, 1 aluminum. All right. Now, because aluminum is replacing hydrogen, hydrogen will then become the element by itself, which looks like H2 because it is one of the 7 Brinkelhoffs. All right. So we've established our products and written the correct formulas for those products. The final step, right, is now to go back and balance. So over on the left side, I have 1 aluminum, 1 hydrogen, and 1 nitrate. Okay? Now, when I look over on this side, I have 1 aluminum again, which is great. 2 hydrogens, and 3 nitrates. All right? Now, if I assign a 3 here on this side, what happens is that gives me 3 hydrogens and 2, right? It does resolve the nitrate issue. So I'm going to have to do something that allows a 3 and a 2 to become the same number. Okay, so we just do a lowest common denominator. So I can't put a 3 there because while that does fix my nitrate, it does not fix my hydrogen. Right? So what I'm going to do, oops, excuse me. 2, okay. What I'm going to do is take the lowest common denominator between 3 and 2, which is 6. And I'm going to assign a 6 here. And a 3 there, and a 2 there. Now what that does, okay, is that gives me 6 nitrates on both sides. Okay, it gives me 6 hydrogens on both sides. Okay, so it balances those 3 in. Now, in adding that 2 there, I am going to have to go with a 2 in front of the aluminum there to finally balance everything out. Okay, next, looks to me like we have a double replacement reaction, AB, CD. All right, so my 2 products are going to be barium with nitrate and lead with carbonate. Doesn't matter which one you write first. Now, looks to me, based on this formula, that we have a +4 here for our lead ion, because nitrate's 1-. So if we have 4 nitrates, right, and 1 lead, that must be 4 and a 1. Okay, and over here, I know that barium's 2+, right, and carbonate, we know based on the back of our periodic table in that list is a 2-. So as I recombine on the right-hand side, I'm going to combine lead with carbonate. All right, so this is going to be a little trickier, but lead carbonate is going to look like this. I have lead and carbonate. Okay, lead's a +4, carbonate's a -2. Now, I'm not going to put a 2 and a 4, right? just going to put a 2 there, because 2 carbonates, 2 negatives 2, would cancel out 1 positive 4. All right? Plus barium, nitrate, barium's plus 2, nitrate's a minus 1. So it's going to be BaNO3 2. Okay? Now, again, if you're still struggling with how I got these formulas, go back and watch those videos. Talk to me, Mr. Huderberg, during class. We can help to resolve that, because if we can't write correct formulas, we can't do anything else properly. Okay? But that's last unit, so I'm not going to spend too much time on that. Okay, so there is my skeleton equation. I now need to appropriately balance this guy. All right, so I've got 1 barium, 1 carbonate, 1 lead, and 4 nitrates on this side. I've got 1 barium, 2 carbonates, 1 lead, and 2 nitrates. Okay? So, in order, excuse me, to get myself to 4 nitrates on the right, I'm going to have to put a subscript or a coefficient of 2 right there, which brings this to 4. Okay, it also brings the barium to 2, which means I'm going to have to come over here and put 2 there, so that I can also make that barium 2, which then also brings the carbonates on the left side to 2. All right, so putting a 2 there and a 2 there, it looks like that gives us 2 bariums, 2 carbonates, 1 lead, 4 nitrates, balanced. Okay, so we should immediately recognize this as a combustion reaction, which means I don't have to think too hard about the products, because I know they're going to be carbon dioxide and water. Again, in this class, all of the combustion reactions we do are going to have a hydrocarbon plus oxygen yields CO2 and water. All right, so we're going to balance out our carbons first. So I got 2 carbons here. I'm going to put a 2 there. Actually, let's write this out first. I got 2 carbons. Hydrogens, I have 5, 6. And oxygens, I have 2, 3. So 2 carbons, 6 hydrogens, 3 oxygens on this side, as it's written right now. Okay, now, so the way, by putting a 2 there, that gave me 2 carbons, 2, 4, 5 oxygens, and the way it's written right now is 2 hydrogens. So again, we're going to start with the carbons, so I'll put in a 2 there, balance my carbons out. All right, I have 6 hydrogens on this side, 2 here, so I'm going to put a 3 there, make that a 6. All right, now I have 4 plus 3, 7 oxygens on this side. Over on this side, I have 3. Okay, so I need to get this up to 7, but I have 2 oxygens there. I can't multiply 2 times a number to get 7, but I do have that 1 extra oxygen there. So if I put a 3 there, that makes 6 plus 1, 7 oxygens. That is now balanced. All right, and our last one, let's say we have HNO3, nitric acid, and gallium hydroxide. So this should be a double replacement reaction. So I'm going to combine the H with the hydroxide, gallium with nitrate. Gallium is a 3+. So it's going to be written as GaNO3 plus HO8, which by the way is just water, written as HOH instead of H2O. It's easy to balance that way. Now, I've got 1 hydrogen on this side, 1 nitrate on the left, 1 gallium on the left, and 3 hydroxides on the left. On my right side, I got 1 gallium, 3 nitrates, 1 hydrogen, and 1 hydroxide. Okay, so I'm out of balance on my hydroxide side. I'm going to need 3 hydroxides over here. That also brings my hydrogens up to a 3, which means I'm going to need to put a 3 here. It also brings my nitrates up to a 3, and I believe that balances us out.